that line to output file. This is what commonly we are doing for each and every line given in source code till you reach to the end in pseudocode. Okay. So with this same flow, we will start with this sample code. Assume I have written program.asm as a programmer. It is having around 8 lines. So this is very simple and basic example. In this example, I have not used literal right now. Gradually, I'll introduce you with a literal and rest of the pseudocodes. Okay. So in short, I'll tell you what the program is doing. It basically starts. After that, it loads the value in one of the register, add it with one of the symbol value, and store the result at resultant location in a memory. And then 5th to 7th statement, if you notice, it is declaring your symbols, whether they are having some value or it reserves some memory. And then the last line is end of the program. Okay, so this is a very simple code. As soon as you observe your code, you have to identify what are the pseudocodes you have used. So can anyone help me to identify which pseudocodes we have in this code? List out the pseudocodes. One of you. Out of 8 lines, which line is having pseudocode? Quickly tell me. Last 2-3 lectures I am discussing about mnemonics and pseudocodes. Quickly help me out.
Ma'am, DC, DS, and.
Very good. DC, DS, end. So DC, DS, though they are declaring statement, but they are assembler directives or pseudocodes only. End is also pseudocode. Any other pseudocode we have?
Ma'am, start.
Yes, very good. Thank you for your reply. So start, DC, DS, end. These are the pseudocode. Again in pseudocode table, when you enter these pseudocodes, no duplicate entries required. All the entries will be unique. Now rest of the thing, if you observe statement number 2, 3 and 4, here we are using mnemonics like load, add and store. Right now by observation we are doing, okay. And now when you reach to the implementation, we are going to give this set and then accordingly your program will proceed. So very first step is we have to keep our all the tables ready. So whenever I'll give next example to solve to you, you have to keep your pen and paper ready. You will be having such a code in front of you. And then on paper, you have to prepare your tables format. So very first table we have to create is mnemonic upcode table or machine operation code table, pseudo operation code table, symbol table, literal table. So before processing start, you have to keep mot and pot entries ready with you. Then rest 2 tables will be updated. Okay. So as per our previous 2 minutes discussion, now you are aware which entry will go in pot and which will go in a mot. So very first line, if I am scanning here, it is having pseudocode start. So I'll enter it in a pseudocode table. Pot table में entry करेंगे उसका. So start is added. Now as a programmer, we don't know the address where the start pseudocode or function will be stored in future. So we will assume function name as a name second column in this table. Okay. Right now we are not using address, we are using name of the function. After that, go ahead and this is why I'm showing line by line. We are scanning it by eyes and just doing the entries in mot and pot. Load. So L is not a pseudocode that we know now. That's why it will go in a mnemonic table. So L is your mnemonic. Assume some hex code or binary code for it. Everyone please mute yourself. Thank you. So for this mnemonic, you have to assume some hex code or binary code here. So I'm assuming 5A. It's a hex code. You may assume anything. Now why I'm saying assumption? Because really you cannot remember all thousands of mnemonics. So it's okay when you assume it. Okay. And if you want actual one, I'll give the list. It is available at the end of the book. As well, I had shared a list, one link in last week. So that also gives you the same thing. Now we are aware L is, now look at the statement number 2. L 1 comma 5. 1 is your register, comma second operand is your symbolic name. So that symbol will be stored in a memory. So can anyone guess what will be the format and length? My
चाय बढ़ा देना थोड़ी, आ रहा हूँ मैं, चाय बढ़ा देनी.
please mute yourself.
अरे थोड़ी चाय.
Sorry for that disturbance. So my question is, load 1 comma 5. 1 is your register and 5 is your symbolic memory location. So can anyone guess what will be the format is? Quickly tell me. Instruction format.
RX.
Perfect. It will be using RX format. And what will be the length for RX format?
32 bits.
Yeah, in terms of byte, it will be 4 byte. So 4 byte length and format. Now here you have to take care, if you are assuming length in a byte format, that is also okay. Bit format, that is also okay. Accordingly your LC will be updated. Fine. Similarly, scan next entry. It is again a A1 comma symbol. So it is a mnemonic whose entry we have to create in a mod table. Assume some hex code for it. Length is again 4 byte and RX format. So like your second statement, third statement is also having RX format. Move ahead. Next statement is also having RX format, but unique mnemonic is there. So add its entry in at third location in mod table. Okay. Now rest of the fields I am updating as per the assumption, and then length and format that you know now. Go ahead. Line number 5 is having DC, that is your pseudo code. So its entry is created in a pseudo code table at second position. Assume some function name for it. So procedure underscore DC, that's why I'm using P underscore DC. You may use anything. Huh? That's your choice. Second column is your choice in pod table. Go ahead. Again you are having DC. So as I have mentioned, you don't have to create same entry again and again. Once it is available, so here you would have understood, before adding any pseudocode, you have to scan the previous entries. If it is already there, no need to update. Okay, same actions are performed, just symbol name and values will be changed. So DC is already there, no need to add. Move ahead. DS is a pseudocode. Create its entry in pod table along with its function name, let's say P underscore DS. Read the next line and the end pseudocode. End is also pseudocode, so added in a pod table at fourth position. And this is how your mot and pot are ready. Now you may say every time you have to initialize this according to the mnemonics. So no, you cannot write thousands of mnemonics and few 50 or hundreds of pot entries. That's why we are assuming whatever we are using, their entries are created in mot and pot. Okay. So actually, when you look at actual assembler, entire set of mnemonics and pseudocode is already stored in some file that will be available for assembler whenever it starts processing. But right now we are doing manual run, so you don't have that list in front of you. So we are creating as per the program. And once these tables are ready, these two tables, you can start processing in assembler, manual translation. Okay. So up to this, any doubt from your side? Everyone understood mot and pot entries? Quickly let me know.
Yes, ma'am.
Okay, thank you for your reply. So next step is, along with creating entries in symbol table and literal table, every time you are going to write line to your output file. So you will open one file in write mode where we will write the lines one by one. So right now you can observe red color output of password on the right hand side of your screen. So some statement, location counter kind of table is there. That table is going to act as a file for me where I can keep my output file, output lines. Okay. So now your journey starts. You recall your assembler. So very first step is you have to initialize your location counter to 0. Okay. So in this animation, my LC value in output file is not yet 0, but I'll initialize, don't worry, in next 2 slides. Then your next job is read the line from input file. So here you can see I'm reading first line from my input file, and here onward please pay attention. I'm going to tell you the use action taken for each pseudocode in password. Okay. So now very first step, read the line from input file. Second step, compare it with pot table entries. आपको check करना है current line is having pseudocode or not. So I am comparing input line with all the entries of pseudocode. Pseudocodes are limited, that's why we are giving preference to. So you have compared at first entry and match found. So match found start is already there in pot. So whenever you get start pseudocode, you have to take 2 actions. Okay. So now you may note it down or you may remember. For start, you're taking 2 actions. Very first step is look at the operand field. Your start is coming with label, that is your prefix, and operand is your suffix. So look at the operand, pick that value. So right now in current line, it is 0. So pick that 0 and assign it to your location counter. So you can notice here I'm writing pseudocode steps for start. So very first step is pick the operand value and assign it to location counter. So see my table, pass1 output table, LC initialized to 0. Okay. Why 0? Because my operand value is 0. If it is 100, so LC will be 100. If it is 50, LC will be 50. Okay. If it is missing, by default it should be 0. Sometimes your start is not coming with operand value. It's optional field, right? So if it is not there, by default LC will carry 0. Otherwise, if operand exists, pick that value and put it here. That is very first step. Now time to look at label field. So your label exists with start. That label name is John. I'm still on first line. Okay. Operand processing done. Assign that value to LC. Second step is look at the label field, that is John. If label field exists, you have to update your symbol table. All the labels are created as a symbols whose entry will be created in a symbol table. So yes, in current line, label exists. So we have to add its entry in a symbol table. Now here you have to keep adding the notes. Okay. So if label exists with start, its entry will be different. Its values will be different. Okay. So whenever add is coming with start symbol, your length is always 1. Remember why 1? Because segment value, John is a name of a segment, name of your program, code segment, or you can say program. So you don't know how much size it will taking right now. So we are keeping it 1. And later on assembler updates that value. So John is going with length as 1 and address is equal to current value of location counter. So you can see your LC value is 0 right now. So I'm going to add that John in symbol table. So look at the ST. ST is updated, red color entry I have created in ST. So first symbol with name John added. Value or address is the value of location counter, which is 0. Length is 1 and relocation required. Now why I'm setting it to R or required? If my starting address is 0, I have entered here 0. But when you load it in actual memory or RAM, it may be anything. 0 say start nahi hoga. It can be 100, 1000, 1000 and 1050, anything. So that's why we have to update this field. इसलिए उसको relocatable बोलते हैं. Constant value which never change, that time only we are going to keep it absolute. In future, I'll take example where you will come to know about the absolute values. Okay. So I'll repeat the step for start pseudocode. It takes 2 steps. First one, operand value is assigned to LC. Second, label is added in a symbol table with a LC value as address and length is equal to 1. This is by default. Okay. And relocation required. So everyone understood use of start pseudocode? What the steps taken by your assembler for start pseudocode in password? आपका ST update हुआ as well as LC update हुआ because of start pseudocode. So these are the two actions taken by your assembler. I hope everyone is connected in a session. Everyone understood uses of start pseudocode? Quickly reply.
Yes, ma'am.
Okay. So only one student is connected. What about others?
Yes, ma'am.
Okay. Thank you for your reply. I expect everyone please pay attention and feel free to ask your doubts. Okay. So job of your first line is over. So write that line to output file. If you recall that flow chart, we have identified it is a pseudocode, taken some steps. Now for start pseudocode, no LC updated. Okay, that's why LC will remain as it is. Length आपका 0 ही है. Length आपका not added in LC for start. That's why LC remains 0. And just write that line to output file. My first entry goes to output file as it is. Okay. This we are going to update in pass2. It will be removed in pass2. There is no except DCDS. All the pseudocodes are removed in pass2, and for DCDS we will allocate the memory. So start को कोई memory allot नहीं होता है. That's why no change in your location counter. So this is what the current scenario is. Okay. Now you are reading next line. आपका control back end of the pseudocode नहीं है. That's why you go back and read the next line and repeat the steps. So your next line is L1, 5. Okay. Now compare L with all the entries of pseudocode. पहला आपका search pot ही रहेगा. If a match found, process, otherwise search mod होगा. So when you compare your L with start, no match found, right? L with DC, no match found. L with DS, no match found. L equal to end, नहीं है. So all the entries of pot आपने check किए, no match found. It indicate L आपका pseudocode तो नहीं है. So what else? You can check a mod table. So now you are giving call to search mod and you start comparing with mod. And very first entry is having a match. L is equal to L. So load found in mnemonic table means मेरे current line पे mnemonic है. So what action we are taking for mnemonic table successful search? We will retrieve the length of a current line instruction. So look at the current line in mnemonic table. L, उसका length आपके third field में, that is 4. Pick it up and reserve in a some temporary variable, let's say L. Okay, so action for pass 1 in a mod table search successful, you have to retrieve length and format. Okay, so length is 4, format is RX. So that is what the step for mnemonic successful search. Set the length variable with the field of mod, third field of mod, that is 4. So green color I am highlighting here. Length variable मेरा temporary variable है, and here I am keeping 4. Current instruction length is 4. Then check label exist. So for that L label field, L के पहले कुछ नहीं है, no prefix. So label is not found. अगर होता तो आपको उसको ऐड करना है symbol table में. Format. So my current instruction format is RX. X indicate symbolic operand exists. It should go in a symbol table. But I am using symbol here. I am not declaring symbol. So that's why when you get declaration, तभी आपको उसकी length address मिलेगी. So right now we will just enter that symbol. Rest of the field are incomplete. Later on we will complete it. So for current instruction, format is RX. So you have to process your symbolic operand. So your current instruction symbol name is 5. We will enter it in a symbol table. So look at your symbol table. Red color में मैंने line add की है. I don't know the address, that's why I have added question mark. I don't know the length, that's why I added question mark. These two fields are updated in future when you get declaration of 5. Okay. So right now these two fields are unknown, but this line will be relocatable. Symbol है memory location change होगा ही whenever you execute. That's why it is a relocatable location. So set it to R. With rest, now you are writing current line, means after updating symbol added in symbol table, current line will be returned to the location counter. So current value of LC is 0. 0 से लेके 4, length of current instruction is 0 to 1, 1 to 2, 2 to 3, 3 to 4. 4 bytes are occupied by your load instruction. Look at here. Okay. So load L is a mnemonic. Right now we are not changing in pass 1. That's why write as it is. Register को touch नहीं करना है. So register 1 will go as it is. But for symbol 5, okay, I don't have address. So that location I have to wait for address. जैसे address मिलेगा हम वहाँ पे डालेंगे. So we will do that step in a pass 2. So what you are supposed to do here, give a reference key from where you will get the address of 5. So I'll search symbol table in future and I'll get the address of it. So I have to add the reference. Now see here, you if you go through a book, यहाँ पे आपको एक dash दिखेगा, blank line दिखेगा. Look at the output of pass 1, second entry, L1, $2 लिखा है मैंने. So that $2 is, I'll tell you what it is, but it is our implementation level change. By observation आपको पता है उधर 5 का एड्रेस डालना है. You can do that, but practically how you will know, right? So what I did for that, I'm referring dollar means symbol table. Okay. Now again confusion, आप सिर्फ symbol table entry number लिखोगे, whether it is my register or literal, that is a confusion. Hence I am adding dollar as a additional prefix to it. So dollar means always keep, as a programmer you have to keep in mind, it is a symbol table, reference to symbol table. So $2. Other alternative is आप 5 as it is लिखो and search symbol table all the entries. But आपका search time बढ़ेगा if hundreds of symbols are there. So to reduce the search time, this is a best way. Dollar means go to the symbol table. 2 means second entry of that symbol table. Direct वहाँ पे जाके आप address location से address निकाल सकते हैं. Okay. So this is what I have added. This is my addition. It's not given in any book, but for implementation it works. So I hope everyone have understood what I did for this current line. If mnemonic found, I have fetch its address, length and format from mod table. Then added symbol in a symbol table. For that symbol, I have added reference in a output line. So these 3 steps we are taking here. If RX format, then only symbol exists and accordingly we processed it. Okay. So L1, $2. तो $2 की जगह future में address of that symbol आ जाएगा. How that we will see in future. Okay. So अभी just fit in your mind. $, means आपको हमेशा symbol table देखना है. 2 means particular index in that symbol table. If you are using linked list or arrays, it may start from 0. So accordingly ये values change हो जाते हैं. So that you have to care when you implement it. So hope so you are getting what I am trying to say. After adding current line to output file, you have to update your location counter because current instruction occupied 4 bytes of memory. तो सेम डेट जगह पे 0 से नेक्स्ट लाइन लिखोगे तो आपका प्रीवियस डेटा ओवरराइट होगा, राइट? हेंस यू हैव टू गाइड योर एलसी, अपडेट इट बाय लेंथ गिवन इन योर टेम्पररी वेरिएबल, लेंथ ऑफ करंट इंस्ट्रक्शन. सो ग्रीन बॉक्स कलर में आपको दिख रहा है. सो 0 + 4 यू हैव टू ऐड 4. सो सी हियर $2 मीन्स व्हाट? सिंबल टेबल एंट्री कनेक्शन, मीन्स आपका आउटपुट फाइल एंड सिंबल टेबल का कनेक्शन एस्टैब्लिश हो रहा है इधर. This entry you are going to refer in future, and then update your LC. So 0 plus location counter added and value will be 4. So next address जहाँ पे next instruction store होगा, that is calculated in LC. So next address is 4, where onwards you will store rest of the instructions. Okay. Now repeat the steps. Go back, read the next line. So you are going to repeat all those steps till you reach to end. So for statement number 3, again you will compare add with all the entries of pseudocode table. Okay, now here I have reduced the step. आपको पता है अभी L compare करके दिखाया मैंने. Same is applicable to AST. So if I compare A with start, DC, DS, end, all will not match, and that's why I'll call search mod. In search mode, first entry will not have a match, but second entry is matching where add exists. Again, time to repeat the steps. As soon as entry found in mod, pick the value of length of that instruction, that is 4 byte. Okay, so length variable set हो गया, again 4 byte. Check the format. Label तो नहीं है, so label exists. No. Continue. Check the format. It is RX. So you have to process the second operand which is in memory. So look at here, second operand name hai 4. So that 4 is not exist in ST, that's why we will update it. So symbolic operand 4 is added in your symbol table. Look at here. In ST I have added third entry, red color mein highlight ho raha hai. Okay. So 4, again I don't know the address and length. I have to wait till it declared. Forward reference हो रहा है. So that line is incomplete. So question mark added for the unknown fields, and the current line is relocatable. So R for the last position. Okay. After that, your job is start writing that line to output file. So when you write line at output file, it is written from 4th byte onward. Statement number 3, I'm writing where the LC value is 4, add 1 comma $3. Now again dollar means symbol table entry number 3. So direct statement में connection binding हो रहा है. Whenever you look up, you will look at the entry number 3, you will get the address of symbol 4. We will insert here in future. Okay. अभी नहीं डाल सकते because we don't have that address. So we are just seeking for the info about these symbols in a password. After that, update your location counter. Last step is update LC. So search pod, search mod, mod से value मिला length का. You have stored symbol in symbol table. Write line to output file. Update LC. These are the 4-5 fixed steps we are taking for mnemonics. So current value is 4. 4 to next 4 bytes are occupied by add instruction. So the address of next instruction will be length of current instruction plus LC. So 4 plus 4 address is 8. So 8th location per rest of the instructions store only. Okay. After updating LC, go back, read the next line from input file. Again you will compare ST with all the entries of pseudocode table. ST with start, DC, DS, end. No match found. Hence you will look up in a mod table. In a mod table, first 2 entry will not match. So आपको क्या करना है, search repeat करना है till you get the end of the table or match is successful, either of. So third entry is matching with ST. We will repeat the step. As soon as you got the ST in a mod table, you have to retrieve the length. So look at this green variable. Again length is 4. Check label exist. So no label exists. In future I'll take any mnemonic with label. I'm going to take different examples. So you will get different cases over there. A simplest form है आपका. No label with any instruction. Check the format. So yes, right now we are having ST1 comma symbolic name. So RX format hai. We have to process symbol RES. Okay. Symbolic operand is going in your symbol table. So look at ST. Line number 4 is added in red color. RES, again reference required. Declaration nahi hai. It just used here. So unknown values are marked with question mark. Length and address. Okay. Write that ST line to output file at location counter value 8. So statement number 4, we are writing at 8th value of LC ST1 comma $4. So dollar represents symbol table 4th entry. Okay. After that, time to update location counter. So LC is updated. Current value of LC is 8. 8 onward, next 4 bytes are taken by ST, mnemonic ST. So next instruction का address definitely उसकी length add करके ही मिलेगा. So current value of LC is 8. Current instruction length is 4. Add them, you will get the next address, that is 12. Okay. After updating LC, you have not yet reached to end pseudocode. So continue, read the next line from input file. Line number 5 you are reading. 4 DC F code value 4. So compare DC with pseudocode table, and yes, you have a match successful in pseudocode table. Pseudocode found. So apply the steps for DC. Now please remember, for every pseudocode actions are different. Okay, सारे pseudocode similar behave नहीं करते हैं. So every pseudocode have its own unique steps. That's why we are writing them in a separate function. So pay attention what we are doing for DC. Mnemonic के लिए आपके steps fix है, but आपके pseudocode के steps different है. So as soon as you got DC, you have to process it. So for DC, look at your label field. DC का prefix है label, that is 4. So we have to search whether this 4 already exists in symbol table. If yes, you will update the entry because DC declare करेगा 4 को. So उसका address मिलेगा, length मिलेगा. So same field ST की आपकी update होगी. If that label not exist, आपको उसको add करना है along with the values. Okay. So DC is coming with label 4. If I search 4 in a symbol table, okay, it's found. So look at here, symbol table entry number 3 is matching with the 4. Label 4 exists there. So time to update the rest of the unknown fields. So यहाँ पे आपका declare हो रहा है, means address मिल जाएगा. So where that symbol gets stored in a memory? Look at the location counter value. What is that right now? LC का current value क्या है? Anybody? Quickly tell me. Current value of location counter?
12.
Very good, 12. So that is the address where the symbol 4 is declared. Okay. So current search that 4 in a symbol table whose address field is equal to LC. So हमने address में डाल दिया 12. You can notice here previously it was question mark. अभी मैंने उसको red color में लिखा है 12. So 4 जहाँ पे है ST में, I'm setting address is equal to 12, जो है आपका current LC का value. Okay. Now look at the operand field. Current line number 5 operand field. DC के बाद का factor देखो. F quoted value 4. So little bit text processing required here. Before the quote, जो भी value है, that gives you the length, and the quoted value gives you the value. Okay. So if you process it, before the quote you are getting F. F indicate one full word. Okay. So one full word means 4 bytes. So length is computed as a 4 byte. So here you can observe in ST, I am setting length as 4. ऐसे ही नहीं डाला है मैंने. Okay. I am retrieving it from the operand field of DC. It may be 2F. 2F है तो आपको 2 into 4 byte करना है. That will be your actual length. We will see such examples in future. So right now F indicate 4 byte. Instead F, if you are getting H, it will be half word, 2 bytes. Okay. So likewise you will get the length from the operand field. Now you may say why it is so complicated, but it is the way of writing instruction for IBM machine. So in that way only we have to retrieve and process it. Okay. So F quoted value 4. So the length I am adding here is from F, not from the 4 quoted value. And then location 12 will carry the value 4 in a pass to. Right now I'll write that line as it is to LC value, current LC value. So write that line to output file. So 12th location पे हमने value 4 store करना है in future. Right now write that line as it is to output file, just for our future reference, nothing else. So as I said, only DC and DS will occupy the memory because they declare the symbol or reserve the memory. So memory में space ले रहा है means आपका LC update होगा. So this current constant is taking 4 bytes, so your LC will be updated by 4. So current value is 12. Current symbol length is 4. So 12 plus 4, it is going to take value 16. Okay. After writing that line to output file, we have updated LC. So it's time to go back and read the next line. Same steps we have to repeat for next symbol. So again, DC is successfully found in pod table, but this time different label is there. Okay, so label 5, search it in symbol table. So location 2 पे आपको 5 मिल रहा है in symbol table. Current value of LC will be an address of that symbol. So now observe the ST. Second entry will be question mark replaced by the current value of LC will go as the address of that symbol. So it is 16 right now. Look at the operand field. F in a quote we have 5. So again F means length will be 4 byte. So आपका symbol table value update हो रहा है 4. Length field is updated as 4. So my symbol table entry number 2 is updated for address and length. Red color में highlight हुआ है. Look at that. Okay. Now time to write that line to output file. So location 16 onwards, 5 DC F5 is stored here. You may observe in output file now. Okay. And then last step is update the location counter. So आपका length है 4 byte जो आपने अभी calculate किया है ST के लिए. Same we have to carry. Add it in location counter 16. So next address is 20. Okay. After that, read again next line. Next line is again having pseudocode found in pseudocode table, but this time we have DS. DC and DS little bit same, but in future you can see the difference. Okay. DC में आप value store करते हो, DS में वो value space blank रहता है. That space reserved in memory will be blank. So for current instruction, DC, DS found. So look at the label field again. Label exists in symbol table at entry number 4. So there you have to update the values. So current value of location counter will be an address of your result variable in ST. Okay, so pseudocode found. So repeat the steps. ST में search हुआ. We are setting LC value to result value address field. So now you may see the difference. Instead of question mark, it is now 20. Okay. Now observe the operand field of DS. It is 1F. So 1 into F. Quoted value missing है because we are not defining any constant for that symbol with DS. That's why quoted value नहीं है. Okay. So 1F means 1 into F. If it is 2F, 2 into F. 100 into F. Likewise. So F always remember it is 4 bytes. So 1 into 4 is equal to 4. So the length field of my result variable will be 4. So observe the symbol table, last entry. 20 is address and length is 4. Okay. Write that current line. Input line number 7 is return at location 20 in output file. Location counter 20. Output file I am writing that line as it is, but that line will take 4 bytes of data. So next address we have to compute. So current value of LC plus length is the next address. दोनों को add करते जाओ. You will get the next location, that is 24. Okay. Again, once you have updated LC, you have to read the next line from the input file. And now you have reached to the end pseudocode. So end pseudocode means end of the program reached. You have to repeat the step. Compare end with pod table. End found means what you have reached to the end. But remember one thing. If any value exists in a literal table, we have to process the literal, then end of the pass one will be there. So right now if you check your LT table, मेरे current example में literal था ही नहीं. So my literal table length is 0. So no literal pending here. So that's why we can stop. Okay. So in pass 1, you have to take care. When you reach to end pseudocode, check the literal table. If any literal is waiting for address, यहाँ से आगे उनको address allocate होता है. But right now, your literal table is empty. So do nothing. Literals अगर है तो process करो, otherwise do nothing. Just write that end in output file and you can hand over to pass 2. आपका literal table green arrow show कर रहा है, it is empty. So that's why you don't have anything. Stop here. So this is what you have generated as the output of pass 1. So symbol table and literal tables are updated during the processing and pass 1 output is partially processed. आपके जो सारे symbols थे, they were replaced by the symbol table references. In pass 2 that references will be replaced by addresses. क्योंकि आपके symbol table में भी address आ गए, right? So जब आप ये सारा data pass 2 को feed करोगे, it will just pick the value from symbol table and put it in a pass 1 wherever required. And then you will get final target code in your hand. So I hope you have understood how the pass 1 processing is done for this simple example. Right now you may feel lot of things you have to remember, but the things are fixed. Once you remember, you can solve any problem given to you. And if you refer the previous question papers, such examples are asked and you were supposed to write pass 1 output or pass 2 output. So if you go back to your pass 1 flow chart, yesterday I had explained, now you have already taken some manual steps, so you will be able to draw on your own. Okay, so quickly what we have done is summarized in this slide. So we read the data, LC initialized to 0, then data read kiya, search for table. If search successful, according to the pseudocode actions are taken. Okay, so with pseudocode DC, DS, start, whatever it is, accordingly processing is done, right? If it is a mnemonic, you are going to process. So pseudocode is coming with symbol, you have to add them in symbol table. If it is literal, you have to add in a literal table. Update location counter for DC and DS it will happen. जैसे symbol declare होता है, LC update होता है. If pot entries are failed, then you are going to search mod table. Okay. So आपका search अगर देखेंगे, you are writing line to output file and then going back, right? And then you are checking if pot fails. Green color is highlighting the vertical path. Search mod table. Extract the length and format. If any literal exists, add in literal table. If symbol exists, add in symbol table. So same thing we have done in a